So we now come to the portion which is the reaction with ammonia, which is NH3. For this we have two parts. Okay, in first part we take ammonia in excess, and in next part we take ammonia not in excess, in a amount. Okay, in the next part it will be unsymmetric bond cleavage, which I will say, and in this part I will just write the product which is formed. Okay, now in this I have three cases. I used NH3 or ammonia in excess, at low temperature, at high temperature in excess, and here you have to remember the condition, which is 450 Kelvin in the ratio 1:20 ammonia. Okay, now what you get from here is, I write from here. Okay, now you have B2H6 NH3 excess at low temperature. You simply write B2H6.2NH3, as simple as that. Okay, now next you have NH3 in excess, but at high temperature you get BnX. This is called inorganic graphite. Okay, here you have NH3, the temperature is provided 450 Kelvin in the ratio 1:20. Now here what you get is N3H6. This is inorganic benzene. In organic chemistry I have studied about benzene, which is C6H6, and in inorganic you have B3N3H6. We will study about the structure of B3N3H6 in the following time, today only. Okay, so copy it up to this much. Next we will move on to the second case about the reaction with amines. Okay, let's move on. So let's now erase this. Now we come to the second case, which is reaction with ammonia, and also with 1 degree and 2 degree amine, but not 3 degree amine. Okay, just a second. So let's write here reaction with NH3 or 1 degree amine or 2 degree amine. Okay, now for doing this, let us first write the structure of boron, diboron. Diboron is like this: B, one here, one here, one here. Okay, I'm sorry, I omitted a thing. So B. This is the structure of diboron. Okay, this is the banana bond. I will discuss it later on. Now here, when you take it with ammonia, 2NH3. Okay, now a phenomena happens here which is called the unsymmetric bond cleavage. So let's write down here unsymmetric bond cleavage. Okay, so let's make cleavage of this bond. I will make the cleavage from this direction. Okay, let's see what is happening. So if we cut the bond from this direction, let's not rub it, otherwise it will look like a massacre. Okay, so if we cut the bond from this direction and then NH3 comes here 2 times, the result which we will obtain here, we get here is, see how much hydrogen is left with boron, BH2, right? We write BH2 over here, NH3 is coming. How many NH3? 2 NH3 is coming, right? So BH3 Okay, let's shift it a bit. So BH2 NH3 whole twice, and 1 2 3 4 again a boron and 4 hydrogen. So this entire thing will be minus and this thing will be plus. Clear? Sorry, this one will be plus and this one will be minus. Clear? Just see a bit, take your time. Okay, will I have to repeat? Okay, I am repeating. Wait, I am doing again. Forget everything. Let's see again. Okay, so what I have, diboron. Okay, so let's draw the structure first. BB, this is the banana bonding or the bridging hydrogen, and here H, here also H, and here also H. Okay, let us take ammonia 2NH3. Okay, now I told unsymmetric bond cleavage, so bond will cut from here. See, this is not symmetric because 4 hydrogen is coming here, 2 hydrogen is coming here, right? So after this 2 ammonia will come here, and now let's write from the left side. Okay, what we have, BH2, right? BH2, ammonia is coming, right? 2 ammonia, NH3 whole twice. What is left here? BH4. So this will be negative and BH4 portion is positive, right? Clear? I did a mistake again, same mistake, sorry. Okay, now the case will reverse when it will be 3-degree amine. Okay, now for that case, 3-degree amine. Now for that case it will be symmetric bond cleavage. Okay, let's write here symmetric bond cleavage. Okay, 3-degree amine and also CO, carbon monoxide. Let me have some water, my voice is drying up. Just a second. Now for this, what happens here is, let us take B2H6 again. We will draw the structure. B, bridging hydrogen, H, Now we have to symmetrically break the bond. Now if you see a thing, if you have to symmetrically break the bond, if you take a 3-degree amine, okay, 3-degree amine is R3N, it will be 2 times R3. Now if you have to symmetrically break this compound, that means both sides will have the same number of hydrogen and boron, right? So if you notice, if we cut the bond in this way, it will be symmetrically broken. See, BH3 and here also BH3, right? So let us now write what is coming. Okay, so it will be 2 times, so let's write it again first, then I will write BH3 R3N. This was this part because it is coming here. Okay, now this part means that this other remaining part will also be same, right? So this will be 2 times, right? So this is the out product. Now if you want, you can multiply the thing, it will be B2H6.2 R3, right? Clear? Now if you take here, in case if you take Cu, okay, the same thing will be formed here, but in that case I am rubbing this Okay, same thing will be found, but in that case you have to place 2 times CO, right? Clear? Copy this much. Next I will discuss about the structure of B2H6. I will tell about the banana bonding, about that. So copy it. Finished. Let's move on. So give heading diboron structure. So give the heading structure. Okay. Now for drawing the structure, I have already mentioned earlier. Let's draw it in a bigger view. Okay. So and here is B. We have the formula which is B2H6. This is hydrogen. Here is also hydrogen. Here is also hydrogen. Here is also hydrogen. Same thing over here. Now if you notice here, if you notice the shape, okay, if you notice the shape, same thing again here. Okay, if you notice this shape looks apparently like a banana, right? If you notice this shape looks apparently like a banana. So this is called banana bond. Okay, so this thing is called banana bond. Right? This is the bridging hydrogen, this is the bridging hydrogen, this is terminal, this is terminal, this is terminal, this is terminal. Okay. Here if they ask you in the question the hybridization of boron, it is sp3. Okay. Remember in BH3 it was sp2, but in case of B2H6 which is diboron, the hybridization of boron is sp3, right? So this was all about diboron. Next we come to few important points about the boron family. Okay, let's erase this. Okay, now we are towards the end of this lecture, so give the heading important points. First is structure of B3N3H6, which I have mentioned. It is inorganic benzene. Okay. So for drawing this, let us take this entire unit as together as C. What we did in organic chemistry, if you remember the structure of benzene, it was some sort of like this. This is the carbon. Okay. Now in case of inorganic benzene, what we do here, we will take this entire thing as C6, C33. Okay, we are just holding, we just let, not C, let us take it H6, H6. Okay. Can you recall the C6H6 formula with this, right? Now for drawing this, we will alternatively add boron and nitrogen in the ring formation, right? So let's see, I am talking about this. I take one nitrogen here, so the next one will be a boron. I need to form a 6-membered ring. Okay, so one, again this will be a nitrogen because boron is there. Alternatively, just change B, here will be N and here will be B, right? Here will be B. Okay, right? Now I have to satisfy the bonding. Now nitrogen will bond covalently with this side, this nitrogen will bond covalently with this side. This is coordinate bond, I'm sorry, not covalent. Okay. Now let's satisfy the hydrogens. 1, 2, and here it will be 3. I did a mistake over here. Let's erase this for the time being. Okay. Structure B3N3H6. So this is the structure. I'm sorry, this will be H. So this is the structure of your inorganic benzene, okay, which is B3N3H6, right? Oops, I did a mistake. Hydrogen bonds will be here. So this is the structure of your inorganic benzene. Note it down. Okay, I did a mistake, so let's do it again. Okay, so it is it. Let's do it again. What I said, we will take alternatively B and N. Okay, so this is B, this is N, this is B, and here it is N. Okay. Now what I will do, I will satisfy the coordinate bondings alternatively. Okay, coordinate bonding done. Now let's connect the hydrogen with nitrogens. Now this one also I will do like this. Clear? So this is the structure of your inorganic benzene. Okay. Now few points about this. This is aromatic. This is more reactive. Okay. This is more aromatic. I'm sorry, this is not more aromatic. This is aromatic, and this is more reactive than your organic benzene, which is C6H6, right? So copy it. Done. Now let's come to the borax bead test. Now if you remember, during hydrolysis of borax we obtained a few things. Let's do it again. Okay, so borax was Na2B4O7.10 H2O. On heating we obtained Na2B4O7. okay, now when you again heated this extremely, you get NaBO2, I'm sorry, NaBO2 plus B2O3. This is called glassy. This is boric anhydride. Wait, remember I did just now in the previous lectures. Okay, now B2O3, this I have to work with this. Okay, now let us see. Bm is many metal plus B2O3, it forms a complex called metal borate, which is MbO3 whole twice. This is called metal borate. Okay, now this metal borate has colors, have different color for different metal, which I will be telling you just now. So which helps in the identification of the D block metals. Okay, so here it was with M plus B2O3. Moving on, let's write here now with chromium. Okay, Cr2O3 plus B2O3. So what we will get here is CrBO3 whole twice, right? This will have a color, I will discuss now. So copy it up to this much. I will now tell you about the colors, then occurrences of boron and aluminum, and then lecture ends. Done. Give heading metaborates, color of metaborates. I am going a bit faster because these are all easier things. Okay, the place where I have to go slower, I went slower there. Okay. Write heading color of metaborate. Okay. Now color of metaborate, it will start from chromium. Okay, if you remember the D series, chromium, ferrous, okay, so this is the D series. Zinc will not come in this category, right? So for this, remembering the color, this is green, right? This is violet, or you can say pink. Okay, this is again green. Okay, this is your brown. Okay, I'm sorry, this is blue, this is brown, sorry. Okay, and this is again blue. So these are the color of metaborates which you can use for identification, right? Now let's move to the occurrences of your boron. Give heading occurrences of boron. Okay, first is your borax, obviously, or you can take the orthoboric acid first, H3BO3, orthoboric acid. So this was the first. Next we have borax, Na2B4O7.10H2O. This is borax. Okay, next we have Na2B4O7, this is 7H2, I guess. No, this is 4H2. This is called carnite. So these are the occurrences of borax or boron, which in which form you can find it in the nature. Okay. Now the last thing which comes here is the occurrence of aluminum. Occurrences of aluminum. Now you have to remember that aluminum is the third abundant element in the earth crust. The first is in the ratio oxygen is greater than silicon greater than aluminum. You can remember it in the way of OCl. Okay, so the occurrences of aluminum, you can find it in the form of bauxite, obviously, which is the aluminum ore. Oxide has a formula of Al2O3 2H2O, Al2O3.2H2O. Okay. Next is you can get from cryolite. Now cryolite has a formula of Na3Al F6. Okay. Now during the extraction of alumina, the cryolite is mixed with bauxite and also with fluorspar. Now cryolite there acts as a catalyst to lower the melting point of aluminum, and your fluorspar and cryolite togetherly acts as a solvent which can increase the conductivity of the molten solution. So this was all about the boron family. I hope you like the crash course series. So thank you for watching.